Now in this video we'll see that our motion of simple pendulum is simple harmonic motion, and we'll derive some equations for simple pendulum. So here we can see a simple pendulum oscillating from this is the mean point A, and this B and C, this is the amplitude of this simple pendulum, where the distance of AB or the displacement of AB equals to AC. Okay, so now if I think about that, what is the effective length of this simple pendulum? This effective length will be this point L. Okay, so this is our effective length L. The bob has a mass of m. The bob has the mass of m, so the weight will be mg working downwards. Now think about that. When this mg occurs, there will be a tension, because we know every action has an equal and opposite reaction according to Newton's third law. So for this action of mg, there will be a tension T working on this thread. Okay, then it creates an angle theta to oscillate. So this and this theta are actually equals. This theta and theta prime actually equals, and this pendulum is oscillating this theta to theta prime point. Okay, so now suppose at B point the mg is working downwards. So what will be the component of these two E and F point? So in this E point, suppose this is theta, that will also be theta. So in this section, that will be our mg cos theta, and this BF section, that will be our mg sin theta. Mg sin theta. So the effective restoring force F on the bob acting towards the equilibrium. So it acting always towards the equilibrium. So in this case, our F will be actually equals to this mg sin theta, but as these are opposite to each other, so there will be use a minus sign. So from that we can find out that F equals to mg sin theta. And there is a relation of, to become a simple pendulum, our theta must be very small. Our theta must not be must not be greater than 4 degree. It will always be less than 4 degree. So in this case, our sin theta will be actually theta, because these theta are very small. So for this reason, we can write this thing as mg minus of mg theta. Okay, so we know for F we can write F equals to ma. Our ma will be minus of mg sin of theta, and here a means the acceleration. So if I cancel out this bob mass m, then I will get a equals to minus of g theta, not sin theta. It will be used as theta. It will be used as theta minus g theta. So what is the value of theta? We know theta is actually equals to the displacement by length. Displacement by length. So what is this? What is the displacement of this value? The displacement is AB, and our effective length is L. Okay, so from that we can write this thing as AB by L, or if we represent this AB as X, then I can write this thing as X by L. So here I can write this thing as A equals to minus of G by L into X, minus of G by L into X. Okay, so as this gravitational acceleration and this effective length are always constant for this bob, so I can think this is our constant value. So for that I find out that A is proportional to minus of X. So our acceleration is actually proportional to the displacement, and it directed opposite to our displacement, and this is the property of our simple harmonic motion. So as I find out this simple pendulum has this kind of property, so I can think that our simple pendulum is a simple harmonic motion. So for this reason I can figure out that our simple pendulum is simple harmonic motion. Okay, I hope you understand this whole equation. Now coming back to the our main point, where we find out that our A is actually minus of g by L into x. Okay, now we'll derive a formula for our simple pendulum, and in our previous video we see that A is actually equals to minus of omega square x. So instead of A, I can write this thing as minus of omega square x equals to minus of g by L into x. Okay, so if I cancel out this minus term or x term, then I will get omega square equals to g by L. So what is the value of omega? Omega equals to root over g by L. Okay, now there is a relation between omega and our time period t. So there is a relation between our omega and our time period t, which is equals to 2 pi by t. So if I write this thing as omega, instead of omega, if I write this thing as 2 pi by t, then I will get root over g L. Then if I solve this equation, then I will get our time period t will be 2 pi root over L by g. So from this equation, this is the time period equation for our simple pendulum. We use this equation to solve mathematical problem for simple pendulum, where L is our effective length and what is g? G is the acceleration due to gravity. So I have to remember only this equation. So we derived a equation for our simple pendulum. Now we will see some laws of simple pendulum. The first law is law of isochronism. So what is this law of isochronism? Means when the angular amplitude of the oscillation does not exceed 4 degree. So at every case we have to remember that our angular amplitude or angular distance must not be exceed 4 degree. It will always be less than 4 degree. Means our theta must be less than 4 degree. The time period of oscillation of a simple pendulum of a fixed length at a given place is always constant, being independent of the amplitude. Okay, so time period of oscillation of a simple pendulum of a fixed length at a given place is always constant. Suppose I have a simple pendulum in this section. If I had a simple pendulum in this part, and I also had same length simple pendulum in this portion, then these two simple pendulum will have the same time period if they have same length, effective length, and at a given place, means these two places are actually similar. They are not actually varied. Okay, so we take same length simple pendulum and I take this in a room, and if I find out the time period will be same for this pendulum and this pendulum, always the same. Okay, so this is the first law, law of isochronism. The second law is law of length. When the angular amplitude of oscillation does not exceed 4 degree, the time period of a simple pendulum at a particular place is directly proportional to the square root of our effective length. So it means that our time period will be square root of our effective length. In this proportional time period will be proportional to the square root of our effective length. This is another property of our simple pendulum. So what is the third law? Third law says that the time period of a simple pendulum for a particular length is inversely proportional to the square root of the acceleration due to gravity. So if our length is constant and our place is varied, then our simple pendulum, the time period of simple pendulum will be inversely proportional to our gravitational acceleration due to gravity. Okay. So fourth law is when the angular amplitude does not exceed 4 degree, the period of a simple pendulum of a given length at a particular place is independent of the mass or material of the bob. So it doesn't mean our simple pendulum. We know the formula of simple pendulum is 2 pi root over L by G. Here we don't find out any term of mass in this section. So so for this reason our time period doesn't affect by the particular place independent of the mass or material. So it doesn't mean what are the mass of our bob, or what material it is constructed. So it doesn't depends on this mass and material. Okay, so these are the fourth law of simple pendulum. These laws are very effective, and these equations are very effective for solving mathematical problem. So now we'll see some use of simple pendulum. What are the uses of simple pendulum? So there is first use of simple pendulum is acceleration due to gravity. We can find out okay, we can find out this gravity value g with this with the formula of simple pendulum. We know our time period t is actually equals to 2 pi root over L by g. So from this equation we can find out our g is actually equals to the 4 pi square L by t square. By this equation we can find out our gravity acceleration due to gravity by the help of simple pendulum. And the second equation is height of a mountain. Height of a mountain. We can find out height of a mountain by this value of g. So how can we find out? Suppose this is a mountain, and here I take a time period of our simple pendulum t, and at this crest of height h, I take this simple pendulum at this crest, and I find out a t prime time period for this for same simple pendulum. Then what will be the equation for this t and t prime? I know t equals to 2 pi root over L by g, and for t prime equals to 2 pi root over L by g prime, because this height is varied, so our g will be also varied. Okay, so if I solve this equation, I will get t by t prime by t is actually equals to the root over of g by g prime. And in our gravitational chapter, if we know g is actually equals to the gm by r square. So what will be the value of g prime? G prime will be equals to the gm by r plus h whole square. G prime means at that point. So instead of root over g by g prime, I can write this thing as r plus h whole square by r square. Okay, so from that I can write t prime by t is actually equals to the r plus h by r plus h by r. Then if I solve this equation, then I will get, if I want to find out the value of h, then I will get h equals to r into t prime by t minus 1. By this equation I can find out a height of any mountain. So this is the another case of using simple pendulum. And the third case is time. Okay, we can make a simple pendulum which can actually calculate time. So we can make a simple pendulum, and we can actually calculate the time of our clock. We can make a clock by this simple pendulum. Okay, so I hope you understand the use case of simple pendulum. There is another kind of simple pendulum which is known as second pendulum, So what is the second pendulum means? The second pendulum says that the time period of a second pendulum is 2 seconds. The time period of a second pendulum is 2 seconds. So if I have said that I am given a second pendulum, then obviously the time period of the second pendulum will be 2 seconds. So that's all for today's video. We derived some equations for simple pendulum, and in this chapter we described what is simple harmonic motion. We derived some equation, we derived energy equations and total energy. Then we see how simple pendulum works, laws of simple pendulum, all of these things. I hope you understand the video. Please like this video and subscribe to our channel. Thank you.